Hey guys, what is happening? Welcome back to another video. Today we're going to be talking about part 2 of digital versus analog servos. Last week what we talked about is the advantages and disadvantages of these type of servos. However, this week what we're going to do is we're going to dive into the application of these servos. Where would you expect these servos to actually be used within our radio controlled vehicles? Now, the way that we're going to do this is we're going to talk about the advantages, the top advantages of both digital and analog by going back into that video and pulling those top advantages out. Then we're going to go ahead and talk about why we would expect to use them within our application here. And then we're going to list out all those different applications. The last thing that we're going to do to end the video is we're going to talk about digital versus analog, and we're going to look at certain specifications of those servos. Then we're going to make an expectation as to what we would expect the result of the servo to be. We're going to be looking for the servo that provides the best performance. So let's get started and talk about our digital servo. Now, digital servos, as we know from last week, is best for performance. When we are expecting the best amount of performance out of our radio controlled vehicle in terms of our control, this is where we want to use a digital servo. Now, there's 3 reasons for that. The first reason is digital servos have the best response time. They're able to respond very quickly. The second reason is digital servos have excellent holding power. This is one of the primary reasons to use a digital servo. Now, when we're talking about holding power, holding strength within the servo, we are talking about the servo's ability to hold its position. If you were to have a servo, and it can be at a neutral position or it can be at any position controlled by the input using your transmitter. If you're trying to hold a certain position with that servo and an external force is applied, something that wants to move that servo out of position, what will happen is the servo will be able to provide a lot of torque in order to maintain that position. The whole goal of the servo is to maintain the position that you have instructed it to hold. And a digital servo is going to be able to do that and do that well. That is what we are primarily focused in on when we're talking about holding strength. The other part of that equation is if you are trying to move within that position, if you're trying to hold this position, but you do have some movement within that sort of small domain, this digital servo is also able to do that. It gives you that finite control, that fine control when you're only putting in a small amount of control input. Those are the top 2 advantages that you get from a digital servo. The other advantage that you get from a digital servo is going to be its ability to provide torque in such a fashion where it is smooth throughout the range of motion as well as the control input. That is the top 3 advantages of our digital servo. Now let's look at why or where we would expect to find this type of servo being used. Now, the primary focus for a digital servo is going to be for its use to be used in an area where you are trying to control the direction of a radio controlled vehicle. You're trying to control the direction of motion. So imagine that the vehicle is already in motion and what controls its position, where it's going to be traveling next. For most radio controlled vehicles, this is going to be whatever steers its position. So let's look at our first example, which is going to be our radio controlled car. I have here our radio controlled on-road vehicle. Now you can imagine for this application, if you have a digital servo, you are going to be able to have very good holding strength. And this is what we talked about as being one of our best advantages. So if this radio controlled vehicle is going in a straight line at a specific speed, let's imagine just a slower speed, somewhere around maybe 50 kilometers an hour or 30 miles an hour, and we're traveling along, and then we provide a small amount of external force. Maybe the road, it has a rock in it and it wants to actually shift it out of position slightly. The digital servo is going to be able to hold that position very, very well in order to give us the confidence that the car continues in a very straight line. This is the primary advantage here of the digital servo and how it applies to our application of a radio controlled car. Now, you can apply this same sort of idea to other areas within radio control. For example, you can apply the same thing within a radio controlled airplane. You can imagine that a radio-controlled airplane has multiple different types of control surfaces used in order to control the direction of motion. That includes ailerons, elevator, and also rudder. Now, what we didn't talk about in terms of its motion is what an airplane uses when it comes to land. It uses what is known as flaps. When those flaps are dropped down, it also has a large amount of surface area that is exposed to the airflow surrounding the flaps. This is a big ask for that servo. We are expecting that servo to be able to hold that position with a lot of torque. These types of applications within our radio-controlled airplane is going to be best suited for our digital servo. You can say the same thing to a radio-controlled helicopter. If you're trying to control the range of motion of that helicopter through the swash plate, it is best to use digital servos there. What you would expect is those digital servos to be able to give you that holding power to hold that specific position in order to have confidence that you can maintain the direction that you're inputting to that radio control helicopter. And lastly, the same thing can be applied to our radio controlled boat in terms of our rudder system. Or better yet, you have a radio controlled boat that uses an outboard type motor. That is a lot of weight hanging off the rear of the boat. And that weight must be supported by the steering servo. That is going to be the way that you actually are able to turn that boat. Here it is also best for a digital servo. Here you're looking for that precise control of the outboard motor when you're trying to steer it. It's not going to have a lot of servo movement. You're just looking for that holding power in order to maintain a certain position. That's going to be what's critical in these applications. Now let's take a look at our analog servo. For our analog servo, what we would expect there is that our biggest advantage is going to be the cost. Analog servos are quite inexpensive, and that means they actually serve a very good purpose for us. Where we would expect to see these servos is in areas where we don't expect a lot of control. We're not worried about holding power. You may see that a good application for an analog servo could be within a radio controlled car where we're trying to select the specific gear, or we're trying to select whether we want to have a locked differential or unlocked differentials. If your radio controlled vehicle has this functionality, an analog servo would be perfectly okay and acceptable. Why? Because we're not worried about the level of torque that we can apply in certain positions. We are just trying to get from position A to position B. It's going to be a full sweep, and then it clicks into that next locked position, and we have hit our target. We've met our goal there. Other areas where you may see analog servos, and it's very well accepted, is within a radio-controlled airplane where you have the gear doors opening. When those gear doors open, you don't need to worry about the level of control and holding power that that servo has to offer. You're also not worried about the type of response speed that you get out of that servo. This is another great reason why analog servos would be used for these specific applications. Now at this point you are probably wondering, we just talked about digital servos and analog servos, and it seems like analog servos are not okay for the primary source of control of your radio controlled vehicle or application. This is not necessarily true. It's only true if you're looking for absolute best performance. Analog servos definitely have their place, and they have their place if you're looking for a cheaper alternative. Now here's the thing. I have here an example of a radio-controlled nano-size helicopter. There are servos that control the swash plate on this helicopter. Now, it's not critical if these specific ones used in this exact helicopter are digital or analog. However, what is critical is to note the application. This is a micro-size helicopter. It is fairly inexpensive to end up getting this in order to have some fun within indoors or any sort of small outdoor area. Now, the reason why that's important is because it's inexpensive, it would not make sense to have expensive servos being used in this type of application. It is perfectly acceptable to use analog servos within this type of application. Now, let's switch gears and look at something bigger and possibly what one could consider a little more dangerous. Let's look at our radio-controlled car yet again. We talked about the radio-controlled car going only 30 miles an hour in the previous area that we spoke about it. Now let's imagine that this is going upwards of well over 100 miles an hour. In this type of application, you want the best performance for your steering servo. It would not make sense for you to use a cheap and inexpensive servo for the control of your steering when you plan to travel at very high rates of speed. The reason why is you want to make sure that you feel extra confident when you are driving this vehicle in a straight line. You want to make sure that that servo has the best holding power or holding strength to keep you in that straight line. It is a lot more critical for this type of vehicle to need the use of a digital servo. If this vehicle is only going 30 miles an hour and you're not so critical about the intense holding power that digital has to offer over analog, then yes, you can use analog servos. In fact, I've used analog servos for many years within all these types of applications that we're talking about today. The difference is I am now looking for best performance so that I have the best control over my radio control vehicles. And especially as my radio control vehicles become faster, bigger in terms of the potential that they have, that's where I'm looking to make sure that I keep everything safe and I want that extra control. Now, the last thing that we have here is a comparison between a digital servo and also an analog servo. Now, we can imagine that the analog servo would be able to deliver about 120 inch-ounces of torque. And we could say that the digital servo is going to be able to offer us 100 inch-ounces of torque. Now, what we're expected is to select the servo based on best performance for a radio controlled car. Now, it might be apparent to us that the analog servo, being capable of delivering 120 inch-ounces of torque, is going to be best suited for our application. We're looking for best performance so that we see these two different numbers, and the 120 inch-ounces is more torque than the 100 inch-ounces by quite a bit, quite the margin. However, this doesn't paint the true picture as to what's going on here. The best servo for our application may not actually be the analog servo. And the reason is our digital servo has a lot of holding power, holding strength when we're talking about keeping and maintaining a position. The analog servo is not going to be able to compete in this same sort of fashion. In order for the analog servo to compete, we would have to have a much bigger differential in torque between the two servos. If we had a lot more torque from the analog servo, then the holding power of the servo would definitely be improved. However, with a small margin of difference, we are going to expect that that digital servo is going to give us much better performance. The conclusion to this is that we would select for best performance our digital servo. Now, if we were looking for more of a budget type servo, that analog servo would be our best option. The reason is we know that analog servos are more than likely going to be cheaper, especially when we're comparing servos of the same size, same speed, and they're going to be only a small margin of difference between the two. So there you have it. That is the one key thing to keep in mind when you're looking at these types of servos. Also, when you do get a digital servo, make certain that you are able to provide the correct amount of power. Digital servos definitely are more power hungry. You want to make sure that your ESC has the capability of powering all the servos that you plan to run if you are using digital. It still applies to analog, however, digital just pulls a lot more power. The second thing for digital servos is that you also want to make sure that your budget, of course, can fulfill what you need there. So there you have it. That concludes the video. I hope you enjoyed this. Don't forget to hit the like button if you liked the video, and don't forget to hit that subscribe button so that I can see you in the next one. Thank you for watching.